Good morning everyone. Today my topic is about comparison of AM techniques. I am G Naresh from ECA section. This is the PPT of analog and digital communications. So let's get into the topic. Analog modulation. Amplitude modulation. Amplitude modulation is a modulation technique where the amplitude of the carrier wave is modulated depending on the information signal, that is the message signal. The frequency range of AM radio varies from 535 to 1705 kHz. It has poor sound quality, but the amplitude modulation can transmit longer distance, more susceptible to, and it is more susceptible to noise. So that in amplitude modulation there lot of noise is present. This is the diagram of amplitude modulation. This required waves. So the inputs of the amplitude modulator are modulating sine wave and the carrier wave as mentioned in the figure. So the output of the modulator is amplitude modulator signal, where the amplitude of the signal is varies in according to the carrier signal. Where the amplitude of the carrier signal is varied in accordance with the message signal as shown. So the frequency of modulator signal and the carrier signal will be same. Types of amplitude modulation. There are three types of amplitude modulation. They are double sideband suppressed carrier, single sideband suppressed carrier, and vertical sideband suppressed carrier. So when we go to double sideband suppressed carrier, here the carrier is suppressed and the two sidebands are transmitted. It is similar process to the amplitude modulation signal. So the DSBSC is transmission in which frequencies produced by amplitude modulation are symmetrically spaced above and below the carrier frequency, and the carrier level is reduced to lowest practical level, ideally being completely suppressed. So the carrier is completely suppressed. In DSBSC modulation, unlike in AM, the wave carrier is not transmitted. Thus, much of the power is distributed between the sidebands, which implies an increase of cover in DSBSC compared to AM for the more power use. So why we are going to the DSBSC is, in amplitude modulation the lot of power is wasted by using the carrier, so that when we suppress the carrier, then the sideband takes more power and the carrier will be less, so that the carrier power will be more. That's why we are going for the DSBSC signal. SSBSC. In the two sidebands in DSBSC are symmetrical, so that hence the same it has similar to each other, so we can transmit only once, that is either LSB or USB. So that SSBSC, single sideband suppressed carrier. SSB means single sideband, that is only one sideband. If the carrier is suppressed or removed, the modulation is called SSBSC. Here carrier and a sideband is suppressed and only single sideband is transmitted. Otherwise, the modulation is termed as SSBC, where single sideband with carrier. Single sideband suppressed carrier is used to transmit audio signals such as speech signal and radio waves. SSBSC transmission does not require an additional sideband to record the signal. A single sideband is enough for the transmission. It results in low spectral range and low bandwidth, which increases the efficiency. A single sideband is enough to transmission. It results in a low spectral range and low bandwidth, which increases the efficiency of the signal. So here the efficiency of the signal is increased. Vestigial sideband VSB, and both the sidebands are not required for the transmission. Yes, the both sidebands are not required for the transmission as it is waste. But a single sideband, if transmitted, leads to loss of information. When in single sideband suppressed carrier, we are transmitting only one while sideband, so that some amount of loss of information has been happened. So hence this technique is evolved, so that we are going for the vestigial sideband. In vestigial sideband modulation or VSP modulation is the process where a part of the signal called as vestige is modulated along with one sideband. So one sideband and a vestige. Vestige means a part of the signal, input signal. It is transmitted. Along with the upper sideband, a part of lower sideband is also transmitted in this technique. A guard band of very small width is led to either side of VSB in order to avoid the interference. VSB modulation is mostly used in television transmissions. Comparison. When we go for the comparison, we going step by step. In AM and then in DSBSC carrier suppressed, in SSBSC one sideband and carrier suppressed, and in VSBSC some portion of signal and a sideband is transmitted. So by comparing all it, we can see that power in standard AM the power is high, and in SSBSC the power is low, because only one sideband is transmitted, so that the power requirement of SSBSC is less. In DSBSC it has two sidebands, so that the power requirement is medium. VSBSC it is less than DSBSC and greater than SSBSC, hence the signal is of a vestige plus sideband, so that it is between the DSBSC and SSBSC bandwidth. In standard AM it is 2 FM, because the carrier to lower sideband it is FM, and the carrier to lower sideband it is FM, and the carrier to upper sideband it is FM. So FM into FM, 2 FM, FM plus FM, 2 FM. So in SSBSC only the one signal is transmitted, so that it is bandwidth is FM, and in DSBSC it is same as the AM, so that its bandwidth is 2 FM. In VSBSC similar to the power, it is lies between FM and 2 FM. Carrier suppression. In standard AM there is no any carrier is suppressing, and in the SSBSC yes, the carrier suppression has been happened, but it only suppresses one carrier. It is suppressed and along with a sideband. In DSBSC yes, only the carrier is suppressed. In VSBSC no carrier is suppressed. Receiver complexity. In AM the receiver is very simple, hence it has a low pass filter, a local oscillator and a demodulator with the modulated signal input. And in SSBSC it is complex, and DSBSC also it is complex, hence the output signal is, we have completely cut off the input signal to the modulation, so that it is somewhat complex to recover the original signal. In VSBSC also it is very simple. When come to applications, the AM is used in the radio communications, and SSBSC signal is very widely used in point-to-point communication and preferred to long distance transmission. And in DSBSC transmission same, it is also transmitted for the point-to-point communication. In VSBSC it is widely and most widely used in telephone broadcasting and other broadcastings. Modulation type. In standard AM it is non-linear, and in SSBSC and DSBSC it is linear. Sideband suppression. In standard AM no sideband is suppressed. SSBSC one sideband is completely suppressed, and in DSBSC only the carrier is suppressed and the sidebands are transmitted, so the no sidebands are suppressed in the DSBSC. And in VSBSC, one sideband is suppressed partially, means some part of the signal. Transmission efficiency. The efficiency of AM is minimum and the transmission efficiency of SSBSC is maximum, and the DSBSC is between the SSBSC and AM, that is moderate, and the VSBSC also similar to DSBSC, that is moderate transmission efficiency. Advantages and disadvantages of application and applications of AM techniques. So the advantages of DSBSC is lower power consumption and modulation system is simple, and disadvantages is complex detection, and applications are analog TV systems to transmit the color information. So the DSBSC signal is very widely used for the color information of the TVs. SSBSC. Advantages of SSBSC are better management of frequency spectrum to low power consumption. Disadvantages are the generation of exact SSBSC is rather difficult, complex detection, and the applications are two-way radio frequency division, multiplexing, and it is also used in point-to-point communications. And VSBSC. When it comes to VSBSC, the advantages of it is a compromise between DSBSC and SSBSC as mentioned previously. Therefore, it is easier to generate than SSBSC. And the disadvantages of VSBSC is demodulation system is still complex. Its bandwidth is about 25% greater than the SSBSC signal. And analog TV broadcast systems are used. So as mentioned previously, VSBSC applications are widely used in analog TV broadcast systems. By this I conclude my topic. Thank you.